Okay, so another type of calculation that we do with concentrations and with solutions is a dilution. A lot of times I'll have a solution, so maybe it's water and salt, or water and HCl, or water and silver nitrate. It's two things mixed together and I have a solution, and I can dilute it by adding more water. So I'm adding more solvent, but I'm not actually adding any more solute. So I can calculate what it's going to change the concentration. I no longer have, remember, the molarity is moles of solute per liter of solution. Well, if I add more water, I now have more liters of solution. So it's going to change my molarity. My molarity is going to get smaller. It's going to be less concentrated. So I'm going to take a sample of the solution. So I'm going to take a known molarity, a certain volume of a certain molarity, and I start with that. And I can figure out how many moles of solute are in that sample before I add more water. Again, we know that moles of solute is equal to molarity times the liter of the solution. So I'd multiply those together to get the moles of the solute. And then I'm going to realize that after I add the water, I still have the same amount of moles of solute, but I now have more solution. So now I can use this formula, moles of solute. That would be the answer I'd gotten up above. Now my liters of solution would be the new volume after I added the water. So if 35 milliliters of 0.65 molar HCl were diluted to 500 milliliters volume, what is the new molarity? So this is talking about before I've added the water. That of is a really important word. When we see a volume of a molarity, it means these two are talking about the same solution. So I'm going to say this must both be before. So the moles in the original solution, the moles of solute, in this case the solute is HCl, is going to be molarity times liters. So 0.65 moles per liter, that's my molarity. And I'm going to multiply it by liters. Note that it gave me 35 milliliters. I'm going to need to convert that to liters, which is 0.035 liters. When I multiply these together, I get 0.023 moles of HCl. So that's how much solute is in here before I add the water. After I add the water, diluted means adding the water, I now have 500 milliliters volume. So now I'm going to use my molarity equation. Molarity is moles of solute per liter of solution. I know my moles of solute isn't changing. All I'm doing is adding solvent. So I put that number on top, and I divide it by my new liters of solution. Again, it's in milliliters. I need to convert to liters. 3 decimal points to the left, 0.500 liters. When I do that, I get 0.046 molar. Now, I would expect if I added more water, it should be less concentrated. So I'm looking for that molarity to go down. Let's check. It started at 0.65 before I added the water. It's now 0.046. It did go down, so it looks like I've done something good. Is there an easier way? Could I do this instead of doing it in 2 steps? Could I do it in 1 step? Yes. What I'm going to do is I'm going to make an equation that basically is going to work in 1 step. And this is great, but there's no problem with doing it on the way we did it on the last slide. I know that the moles of solute, in the last problem, one of the problems we were using KMNO4, but it could be any solute. Moles of solute is molarity times the liters. Again, in this case, would be the molarity of the strong solution before we added water, times the liters of the solution that we had before we added water. That's why I'm writing strong. Strong meaning before we added water. That's going to be my moles of solute. Note that my molarity of the diluted solution is always moles of solute over liter of solution. My moles of solute is this. And then per liter of solution, this time it's going to be of the diluted solution. If I rearrange this, I find that the molarity of the diluted is the molarity of the strong times the liters of the strong divided by the liters of the diluted. Now, a lot of times we don't say dilute, we often say weak, so it might say weak. But I could do the molarity of the dilute times the volume of the dilute if I rearrange this, and instead of saying liters, I'm going to say V for volume. But understand, it better be in liters. Molarity of the dilute times the volume of the dilute equals molarity of the strong times the volume of the strong. This equation now becomes very useful for a lot of reasons. One, as long as I know 3 of these, I can solve for the 4th. And because there's no fractions here, it's very easy to rearrange algebraically and find what I need. So a lot of times you'll see people write M1V1 equals M2V2. That's basically the same equation, or MS for strong, VS equals MW, VW, S for strong, and W for weak. This is a very powerful formula. It can only be used for dilution. There's an assumption that the moles of the strong and the moles of solute in the dilute are the same. And that's only true when I'm diluting. It's not true when I have a chemical reaction. So only use this for dilutions. If you have different chemical solutes, it won't work. Or it will only work sometimes. So let's practice. Okay. The core of the dilution problem is that the moles before you add the water of solute is equal to the moles of solute after you add the water. And in fact, molarity times volume is moles of solute. So really what we're doing is saying the moles of solute before is equal to the moles of solute afterwards. So the only thing that's changing is the volume of solution. And this is again another form on the last page. Instead of using, I'm using weak instead of dilute as I had it on the last page. It's the same formula. I want to make a table of the, you may want to make a table of the molarity and volume values. It's very easy when you're reading these word problems to get them switched around. So I like to make a table. I want to know the strong and the weak, and I want to know what's the molarity and the volume. And I'm going to read, and I'm going to look for clues to tell me what goes where. How much 4 molar HCl stock solution should you use to make 60 milliliters of 0.200 molar HCl? So I'm going to just write down the things that I know. Note stock solution. That stock solution is a key word that means before dilution. It means sort of what you have on your shelf before you added water. Also, this of, again, of means that these two numbers are talking about the same solution. I need to figure out whether they're talking about, so since this is talking about before I've added water, this is the strong, that means these must be talking about the weak. So I'm going to put the 0.200 molar and the 60 milliliters, which is really 0.0600 liters. In the weak, this molarity, this is the volume. That means that this 4 molar HCl is the molarity. So the thing that I should be solving for is volume of the stock solution. Let's reread. How much, that's volume, solution should you use? So yes, that's exactly what I'm going to be solving for. So now that I have my numbers, I can just plug it into the equation. 4 is for the strong, 4.00 molar times the volume of, I'm just going to leave V or X or whatever variable you want to use. And on the other side, I have 0.200 molar for the molarity of the weak, times 0.0600 liters for the volume of the weak. And what happens if I multiply this together, and then I'm divide both sides by 4 molar, the molarities are going to cancel out, so I didn't need to actually change it out. But if I couldn't see it canceling out, I could always replace capital M with moles per liter. So this is going to be 0.2 times 0.06, divided by 4, it works out to be 300 times 10 to the negative 3, or 0.003 liters. I could also convert that to, sometimes they ask you for how many milliliters. This I could convert to 3 milliliters by dividing by 1,000. 0.003, I'd move it, so I'd multiply by 1,000. I move the decimal point back 3 to the left, and I get 3. 3 to the right, sorry. So this is how a lot of these dilution problems know. If you can recognize it's a dilution, make a table, use this formula, you should be able to do pretty good at the dilution problems. Let's try this one. How many liters of 6.0 molar HCl do I need to dilute to make 1.0 liter of 1.0 molar HCl? Again, let's make our table. I don't know what I've done here. Oh, I didn't do it here. All right. So I know molarity and volume, strong, weak. How many liters of 6.0 molar HCl? So I know 6.0 is one of the molarities. Do I need to dilute? So I'm going to dilute the 6.0. That means 6.0 must be the one that's not yet diluted, the strong one. Dilute to make 1 liter of 1.0 molar HCl. Again, that of means these two go together. This must both be talking about the weak solution, 1.0 molar and 1.0 liter. Note a couple things. I know that my strong molarity should be a bigger, higher number. It should be more concentrated than my diluted molarity. So I'm expecting 6 to be bigger than 1. It is. Also, on the volume, I expect my diluted volume. I added more water. So I should have a bigger solution volume than I do of the, after the dilution than before the dilution. So sometimes you can use the size of the numbers to help you figure out which one is strong, which one's the weak. MS VS equals MW VW. So I'm going to put 6.0, and I can use capital M or I can use moles per liter. I'll use capital M. This is the thing I don't know, so I'm just going to leave V equals molarity of the week, 1.0 molar, volume 1.0 liter. Note that 1 times 1 is 1. This would be molarity times liter for my units. I'll divide both sides by 6.0 molarity, 6.0 molarity. My molarities cancel, and I get that the volume equals 1 divided by 6. Let's see, it's half of 0.33. 1 divided by 3 would be 0.33. It would be 0.167. My units would be liters, which they should be. This is volume. So that's 0.167 liters. I could also write, this is say how many liters, so that would be my answer. And that's how we work these dilution problems. Let's stop it.